Let's talk stretching. When we are doing these sine and cosine waves, there are two kinds of stretches that we're going to talk about. And here's your two vocabulary words: amplitude and period. An amplitude is going to stretch the graph up and down. So it's going to take your wave and make it taller. Your period is going to stretch the graph left and right, side to side. So take your wave, make it longer, make it shorter. That's what the period does. So those are our two new vocabulary words, amplitude and period. Let's actually look at an example and see what they do. So we're going to come to your notes, number 5 right here. And we're going to start with number 1, or the first one on number 5, I should say. Okay, so if I look at this problem, I have two numbers that are happening in this problem. I have this 8 and this 6. One of those is my amplitude, stretching up and down. One of those is my period, stretching side to side. The number in front is an amplitude. So we would say our amplitude is 8. And we are actually just going to ignore that negative for a little bit. We'll come back to that negative at the end. When you write the amplitude, if there's a negative in front, just ignore it for a while. The 6 is your period. Now, I'm not actually going to do the period yet because it's a little weird. We'll talk about that one in just a second. Now, I do want you to notice that both of these numbers are multiplying. It's 8 times cosine, 6 times theta. By the way, this theta is the same thing as x. It's just a variable. But both of these, amplitude and period, are a number times something. That's going to be a very important idea for our next lesson. Okay, now let's talk about how to graph this. Now remember we said our amplitude is going to stretch the graph up and down. So this amplitude is actually going to tell you how many we go, 1, 2, 3, 4, 5, 6, 7, 8, up from the middle. So from the middle, I went up 8. And that's going to be the top of my wave. My wave's going to go up to that point. To find the point your wave goes down to, you're going to go down the amplitude amount. 4, 5, 6, 7, 8. So now I went down 8. And you can kind of see that we're starting to create some boundaries for our waves. So these waves will go up to the top, down to the bottom, top to bottom to top, that sort of a thing. That's what the amplitude does. It gives you a top boundary and a bottom boundary for your wave, kind of like you're fencing your wave in. Now let's talk about the period. The period is the 6. Now, we actually don't just go 1, 2, 3, 4, 5, 6 and draw lines like we did with amplitude. Period is a little bit weirder than that. This 6 means that I am going to have 6 waves. So like we had our waves up here, I would have 6 of this wave shape in one cycle of the circle. So in 2 pi, because there are 2 pi radians in a circle. So this isn't 6 wide, it's how many waves are in a circle. So to get how wide my curve is, I have to do 2 pi divided by how many are in a circle. It is always 2 pi, always divided by, at least for sine and cosine, what we're doing. And then we can simplify that. 2 6 simplifies simplifies to 1/3. I'm actually going to do all this purple. So that is the width of my curve. My curve needs to be pi-thirds wide. So what I'm going to do is make some tick marks. This first tick mark is 1 pi-third. Second tick mark is 2 pi-thirds. 3 pi-thirds. 4 pi-thirds. And I can go in the negative direction. -1 pi-third, -2 pi-thirds. And I want to go pi-thirds wide. I'll have another barrier on my center. And now I've created some side-to-side fences, some side-to-side barriers for my curve. So you can see right here, I've kind of fenced in this area. That fenced in area needs to fit my curve. So what that means is I'm going to go up into the equation. This is a cosine, that's what the equation says. And I know from the last video that my cosine wave starts at the top, goes down to the bottom, and goes back up to the top. So I can come back to this problem and say cosine starts at the top, goes down to the bottom, up to the top. And that would be what I would fill in right here. I would make that shape fit my box, except for one problem. Now let's talk about this negative. That negative comes last. All that negative means is I'm going to take this curve and I'm going to flip it. So instead of going top, bottom, top, I'm going to go bottom, top, bottom. And that's the shape I'm going to fit in this box. So bottom, up to the top, down to the bottom. I fit that shape to my box. And that is one wave of our cosine graph. But we know that this graph is periodic, meaning that it's going to repeat this wave over and over and over again. So if I come to this graph, if I know that this was pi-thirds wide, I can make another barrier that's also pi-thirds wide, and then I can put another wave shape into that new barrier. So now you can see this periodic thing. I'm repeating this shape over and over and over again, periodic. We can even go to the left instead of to the right. Let's go pi-thirds width this direction. And now I've created another box that I can fit my cosine shape wave into. Bottom, top, bottom. And now we're starting to see this repeated wave shape. That periodic piece of the puzzle. And that is actually our answer. You could keep going and keep repeating the wave if you wanted to, but I just want you to have at least 2, maybe 3 waves drawn, so I can see that you know it repeats itself over and over. So that is our first example. In the next video, we'll try another example with a different equation.